আসসালামু আলাইকুম সবাইকে। আশা করি সবাই ভালো আছেন। আমরা আজকে চ্যাপ্টার মানে বেসিক্যালি জেনারিক প্রবলেম সলভিং এসএসসি ক্লাস, দ্যাট মিন্স ক্লাস 9, 10 এবং এসএসসি তে যারা আছেন তাদের জন্য আমরা আজকে প্রবলেম সলভ করব। আমাদের যে অফলাইন ব্যাচ আছে, অফলাইন ব্যাচে ভাইয়ারা এবং আপুরা আমাদেরকে কিছু প্রবলেম দিয়েছেন। সেই প্রবলেমগুলোর বাংলা ভার্সনের ক্লাসটা অলরেডি আপলোড হয়ে গেছে। এখন আমরা ইংলিশ ভার্সনের ক্লাসটা আপলোড করার জন্য আমরা রেকর্ড করছি। রেকর্ড শেষে আপলোড করে দিব ইনশাআল্লাহ। তো আমাদের আজকের যে প্রবলেম গুলো সেগুলো হচ্ছে চ্যাপ্টার 2 থেকে। চ্যাপ্টার 2 আপনারা সবাই পড়েছেন, মোশন, এই চ্যাপ্টার থেকে। এখন একটা কথা বলে নেওয়া ভালো যে শুধুমাত্র যে এসএসসি তে বা ক্লাস 9, 10 এ যারা আছেন তারাই এই ক্লাসটা ফলো করবেন তা নয়। যারা এইচএসসি তে আছেন আপনারাও চাইলে এই ক্লাসটা ফলো করতে পারেন, কারণ আপনাদের চ্যাপ্টার 3 ডাইনামিক্সেও এরকম টাইপের প্রবলেম আসবে। কিছু কিছু ক্ষেত্রে এগুলো সিকিউ তে আসবে, এমসিকিউ তে আসবে। তো ট্রাই করে দেখতে পারেন আর কি আমাদের সাথে ফলো করে। হ্যাঁ, ঠিক আছে, কথা না বাড়িয়ে আমরা ম্যাথে চলে যাই। আজকে যে প্রথম ম্যাথটা আমাদের সামনে আছে সেটা বলা হচ্ছে, কি বলেছে, a car is moving on a rough road creating uniform deceleration or retardation. Okay, in its first 40 seconds the average velocity, এখানে average velocity কথাটা important, the average velocity of the car is 18 kilometers per hour. Okay, and বলেছে after 1 minute of starting, মানে শুরু করার 1 মিনিট পর, after 1 minute of starting its velocity is 9 kilometers per hour. After this the car comes to a stop crossing some more paths. তাহলে আমি বলতে পারি যখন আসলে এই কারটার মানে ঘটনা শেষ হয়েছে তখন মানে ফাইনালি তার ফাইনাল ভেলোসিটি হচ্ছে কতটুকু, 0 মিটার পার সেকেন্ড। And since the car is moving on a rough road creating uniform deceleration, this tells us the initial velocity obviously is not equals to 0. ঠিক আছে? You have to keep that in mind as well. Now, we have want to know in number C. Number C question is, what is the magnitude of the deceleration retardation? As we know, if a car is moving forward with a velocity of u, if there is a deceleration, that means the deceleration is in the opposite direction of the initial velocity or the distance the car is crossing. Anyway, so we don't need to discuss the distance direction here. We just need to find out the magnitude of the deceleration or retardation. Then it asks, how much time would the car take to come to a stop and what would be its total crossed distance? So finally we will need to find out or calculate the time it takes to come to a stop and the total displacement or total distance is processed along the whole time. Okay, so as we know, during the solution of a problem we need to do, for the first thing we need to do is to draw the picture, draw a figure of whatever is happening here, because প্রথমে যদি আমরা হচ্ছে কি আসলে ইকুয়েশন গুলো ফলো করা শুরু করি, there are a lot of equations in motion, প্রত্যেকটা ইকুয়েশন যে আমরা ঠিকঠাক মতো আসলে বুঝতে পারবো যে we have to use this or we have to use that, it's not true. And sometimes finding out equations based on what is given is a bit messy. It's a bit confusing. So this is why I always instruct my students to get the figure drawn first. That will help you to understand what figures or what quantities are given and what quantities do you need more. Okay. Anyways, so what we will do is draw the figure first. What does it say here in the question? It says a car is moving on a rough surface. So let us assume this blue line is that rough surface or rough road, where the car is moving. And let's also assume that the car will be starting from position O. So that means the t is equals to 0. The timing will be starting from position O. And we can safely assume that when the car is in position O, it has a initial velocity of u meter per second, which is unknown to us. We do not know the velocity or the magnitude of this initial velocity, but let us assume it has one. Okay. And since it says that the car is creating uniform deceleration or retardation, let us also assume that while crossing this road, it is facing this red acceleration or deceleration in the opposite direction. Okay. Now what it tells us is in the first 40 seconds. So let's assume after t is equals to 40 seconds, the car reaches point A. Okay. And after, in its first 40 seconds, the average velocity, they say, the average velocity. So when we calculate average velocity, if you guys remember, we have taught you the definitions of average velocity. It is in our playlist for chapter 2. Please visit that. You will understand. So we express average velocity as a V bar. There's a line above the V. So it's called V bar or bar V. So V bar is equal to total displacement over total time. We all know this. We should know this. Okay. So when they tell us that there's an average velocity, what we need to contemplate is the total displacement for this whole time. We know the total time here in this scenario, when they say in its first 40 seconds, the total time is basically 40 seconds. So what will be the total displacement? According to the figure we just drawn, the total displacement is, let's say, S meters, that is OA. Okay. The path OA is the total displacement in 40 seconds. In 40 seconds. So if we input these values, bar V is equals to total displacement S, that's what we assume OA length to be, S, divided by its 40 seconds of time. Now, if we input the value bar V as what is given here, V bar is 18 kilometers per hour as given in the question. Let's input that here, 18 kilometers per hour. Now, we should always convert these kilometers per hour into SI units, that's meters per second or meter per second. So if you want to do that, what do we need? We need to see bar V equals to 18 into 1000. For kilometers, we multiply 1000, and for the hour, we divide it by 3600. This should give us the meter per second, which is, if you calculate, is 5 meters per second. Okay. I would really wholeheartedly advise you not to use calculator at this point. You can just simply do this. 18 and 3600 gives you 200, and 200 and 1000 gives you 5. You can do this in your head. Okay. So please always make sure to do this type of calculations in head, because that gives you an advantage when you will not have the calculator to calculate, say, in your admission tests 3-4 years down the line. It will be very handy for you to do these calculations in your head. Okay, and it also gives you extra brain power. That's only my opinion. The rest is up to you if you want to follow it. Anyways, so what we have here is, now we have calculated the bar V into meter per second, and according to the whole thing, we can say this 5 is equal to S over 40. Picking this up from here, we can write this, right? 5 is equals to S over 40. That means what it gives us is the S distance is 5 times 40 or 200 meters, right? So we can say, if we assume that the OA length it crosses is 200 meters. We have that now with us. Okay, this is a very important thing to have. Now let's further proceed in the question. It says after 1 minute of starting, its velocity is 9 kilometers per hour. So that means this is not an average velocity, this is an instantaneous velocity. Okay. This is an instantaneous, oh, my bad for the spelling, instantaneous velocity. So what is the instantaneous velocity here? 9 kilometers per hour. But when? Instantaneous velocity means a velocity at an instant. When is this velocity? It says after 1 minute of starting. That means from t is equals to 0, let's say it comes to point B at t equals to 1 minute or 60 seconds. So when it is at point B, it has a velocity, let's say that velocity be to be V. Okay, not V bar anymore, that's V. V is equals to 9 kilometers per hour. So if we want to summarize this, what do we have? We have, for part OB, the object takes 60 seconds of time to complete, and the velocity at B is V. V is the velocity at point B. That's V. Okay. What is that? That's 9 kilometers per hour. If you look at the question here, see, after 1 minute of starting, its velocity is 9 kilometers per hour, which we termed as that instantaneous velocity. And you can look at here that when it reaches B, we are indicating that it has a velocity of 9 kilometers per hour. Now, since 18 kilometers per hour becomes 5 meters per second, we can safely assume 9 kilometers per hour is 2.5 meter per second. You should not have any problem doing that. Okay, so we have this as well. This is also given to us. And what else do they say? After this, the car comes to a stop, crossing some more paths. So let's assume it comes to point C. When it comes to point C, it has an instantaneous velocity of v prime. Let's say when it comes to C, at C, now for OC path, the time is unknown. I don't know how much time it's going to take to come to point C from point O. Say, here is point O. It crossed the whole thing here to point C. And after it comes to point C, it comes to a stop. So this V bar will be 0. See? At point C, the velocity V bar, velocity at point C, velocity at point C, what is that? That is 0 meters per second. That's good. So what do we need to calculate? First of all, we need to calculate for C, for the problem C, we need to calculate what is the value or magnitude of acceleration, and for the question D, we need to calculate what is the time for OC path to complete. How much time does it take to come to a stop? How much time would the car take to come to a stop? And then it asks us what is the total distance of OC. How much distance, total distance does it cross? So you need to find out these three things. So if we want to calculate the acceleration for question number C, you see, we can take this path OA into consideration first, because in the path of OA, you see, your object has an initial velocity of u. It crossed for a certain time t, 40 seconds of time, and it crossed a certain distance of s, which you know now, SOA is equals to 200 meters, right? So we can easily use the formula S is equals to ut plus half at squared. Remember, as we told you first, that this u meter per second velocity is a what? Unknown to us, and also A is an unknown to us. So for this OA equation, we have two unknowns, and to solve for two unknowns, we need to have at least two equations. So the first line we are taking is for OA. For OA path, S is equals to ut plus half of it squared. If you input the values here, for S you input 200. You don't know what is your u, so you put u there, and the time there is 40, okay, plus half times A. What is your acceleration? You don't know that, so that's remaining as it is, and 40 squared because you took 40 seconds of time to get there. Now, if you complete the calculation, it gives us 200 is equals to u. Basically, this will be 40u. This will be 40u plus, and I know that's going to be 1600, and if you divide 1600 by 2, that should give you 800, 800A. Okay, so you get this from this. Okay, anyways, now what you can do is to simplify this whole scenario, you can divide the whole thing by 40. 200 by 40, you can do this. 40u by 40, you can do this as well. Plus 800A divided by 40. We are just doing this to get a more simple equation here. Okay, so what you get is 200 by 40 is 50, I'm sure, probably, or 5, I'm not sure. 5 into 40 is 200, yes, not 50, it's 5. See, I also make mistakes, we all make mistakes. Yes, so 5 is equals to u plus for 800 divided by 40 is equals to 20. That's 20. So this is your first equation. This is your first equation, equation number 1, where you have two unknowns, u and a. So for OA path, you got this. Now what you do is you take OB path. For OB path, if you follow this equation, v is equals to u plus at, because you know exactly what your velocity is going to be at point B. It's written here. At point B, your velocity is what? Your velocity is 9 kilometers per hour, or as we have stated in the next slide, this is v is equals to 9 kilometers per hour, or 2.5 meter per second. So for OB, you know the final velocity. To cross the OB, you know how much time it took. T is equals to 60 seconds. And if you consider OB to be your path, then the point O velocity, which is u, is your same unknown that you need to know. You see, you can use OB for the path. You can use the equation v is equals to u plus at. V is equals to u plus at for the path OB. Remember, if anyone wants to take path AB, then the initial velocity will not be u, it will be something else, u prime, because if you take the path AB, then the velocity at point A will be your initial velocity, and we don't want that, because that only creates another equation, another unknown. We don't need that. So we are sticking with OB here. Okay, we are sticking with only OB. So let's go there. For equation or path OB, we have v is equals to u plus at. Now v is equals to 2.5. We all know that u is something we don't know, and 60 you can term as your second equation. Now you just have to simply subtract 1 from 2. If you do that, you see, if you write the number 1 equation here, 5 equals to u plus 20a. And if you write the equation number 2, 2.5 is equals to u plus 60a. What you get is, if you minus it, you put a minus sign here, a minus sign there, and a minus sign there. So you got 2.5. 5 minus 2.5 equals to 2.5. Your u gets cancelled, and you get a minus 40a. So if you calculate what is a will be negative here. 2.5 divided by 40 gives us minus 0.0625 meter per second squared. This is your deceleration. So what you say is, so the magnitude. So the magnitude is 0.0625 meter per second squared. Please notice that when I'm saying the magnitude, I'm not putting any minus sign here, because the negative sign only indicates that it is in the opposite direction to the initial velocity, and so on. Okay, you have to keep that in mind. So when you write the magnitude, you don't put the minus sign, and there can never be a minus sign in the answer here, because they are asking for the magnitude in this question. If they ask what is the deceleration, then you could say, if they ask what is the deceleration is minus something, you could say that. But when it comes to the magnitude, you don't put the negative sign here. Okay. Anyways, number D, how much time would it take to come to a stop? So if you want to find out how much time would it take and what will be the total distance crossed, what you obviously need to find out is, do you know what? What is the u here? You need to find out what is the u here. And so for the question B, the first thing I'm going to do is put a equals to minus 0.0625 in equation 1. So what was that? Our equation number 1 was this: 5 is equals to u plus 20 into 0.0625. And as you have seen, I have not introduced a minus here, so I'm going to put the minus there. Please do not make the same mistake as me, or you will be punished. 20 into 0.0625 gives us 1.25. So u minus 1.25 is equals to 5. So u is equals to 5 plus 1.25, or 6.25 meters per second. So your initial velocity of the car of the object was 6.25 meters per second. Now what do we need to do? We need to find out how much time does it take to come to a stop, right? So if we figure out that now we need to calculate for the path OC, because it asks how much time would it take the car to come to a stop. That means our final velocity V prime will be what? 0, right? So path OC has an equation of V prime is equals to U plus AT. Now V prime is equals to 0. U value is 6.25 plus acceleration is minus 0.0625 times the time t. Okay. So what do we need? We need to find out the time here. So t is equals to minus 6.25 divided by minus 0.0625. You can clearly see that the value is going to be perfectly 100 seconds. Okay. So the time to come to a stop for the car is 100 seconds. And if the time is 100 seconds, then for path OC, we can say S is equals to UT plus half of AT square. The total distance, let's say that be S1. Okay, so S1 is equals to U is 6.25 times 100 plus half times minus 0.0625 times 100 squared. You can follow this formula, or you can write for path OC, V prime square is equals to U square plus 2 into A into S1. So S1 equals to will be basically minus U square divided by twice A. You can also calculate it from that position as well. It will always give you the same thing, minus divided by 2 into minus 0.0625 and 6.25 whole square. That will be your figure. Whatever you do, all the calculations will be same and the magnitude will remain 6.25 divided by, it is 312.5 meters. Either you calculate from this method or from the second method. Either you do this or you do this. So this is or, either you do the blue line or you do the yellow line. You don't do both. This is also 312.5. That's it. I think you guys have understood what did I do to solve this problem. If you have any questions, please comment in the comment section and we will definitely get back to you. Anyways, let's move on to the next problem. What does it tell us? It tells us a mass of 200 grams is thrown vertically upwards with 98 meter per second velocity. In number C, they have asked us to determine or calculate the maximum height of the object. And number D is, if the object was thrown from a height of 100 meters, how much time would it take to return to the ground? That's what they have asked us. Okay, it's a very fine question. So as we have said, whenever we are solving problems, especially for motion and kinematics, it's always a good idea to draw the figures, to draw the picture and understand, have a complete understanding of what's going on there. So that's what we are going to do. Let's assume that this is a ground level. Okay. So from this ground level, we have an object that we are going to throw vertically upwards. Okay. So what we are going to do is throw this vertically upwards. So the velocity will be vertically upwards. With what velocity they are saying? They are saying it will be with 98 meters per second. Let us term this velocity as u, not v. Let us term this as u, as this is the initial velocity, this is the initiation of the whole thing. So let us term this as u. And it says the mass of this object m is 200 grams. That means it is 0.2 kilograms. Okay. So if it has a mass, it has a weight, and the weight is always working vertically downwards. So mg will be always vertically downward. There is no question about it, hopefully. Now what happens here? Since it has a weight, it will always decelerate vertically downwards, but since it has an initial velocity upwards, it will go upwards. And let's say it reaches to a point B. It reaches to a point B when, after reaching point B, it cannot go anymore upwards, because then the final velocity of this object becomes 0 meter per second. So that's the ceiling it reaches. Okay. So what we are assuming is an object is starting from the ground A and it is moving upwards, and after it comes to the position B, its final velocity is 0 meters per second and it cannot go anymore upwards. So the length of AB, so the length of AB, as we see, is vertically upwards for this object to cross, and let us assume that to be y. Okay, let us assume that to be y is equal to AB is equal to its vertical displacement, the vertical displacement for this object. Okay, let us assume it to be that. Now, for this vertical displacement, the object, after reaching to point B, its final velocity is 0. So that means it comes to a stop. So that means for a moment, not totally, for a moment, then it will follow down, because it will fall down because there is a weight of this object which is working vertically downwards. We are not, just nullifying it ever, right? So since it's a free falling body, it is obviously a free falling body. Any object that is under the influence and only under the influence of gravitational acceleration is a free falling object. Doesn't matter if it's going up, doesn't matter if it's coming down. It is always a free falling object if it is only under the influence of gravitational acceleration. Remember this. So anyway, so it's a free falling object and the vertical displacement is y and its initial velocity is v, its final velocity is v. So if you calculate this whole thing and think about it, the only equation that should come to your mind is for path AB, obviously for path AB, is v square is equals to u square plus 2gh, right? This is the equation that it should come to your mind. But because you want to calculate the height. But what you have to remember is this height, h, is given by y in our math. Or that's what we assume, that this height is y. And one more thing, since this equation is only for vector quantities, right? This is never for scalars. This equation is for vector quantities. So that means the direction will obviously follow here. The directions will need to be assumed here. Okay. So if you see the final velocity, though it's 0, you will learn it in later classes. There is something called the zero vector. The magnitude becomes 0, but direction doesn't vanish. So the direction for this velocity is upward, because before it became 0, it was moving upwards. The direction for the initial velocity is also what? Upwards, right? Now for the vertical displacement part, we know displacement to be from the initial position of an object to the final position of the object. Now for this math, our object starts from point A. So the point A must be its initial position, right? And after it comes to a stop momentarily at point B, we can say for the maximum height thing, this point B is my final position of this object, right? Now, if that's the case, what is your displacement? From initial to final, from initial to final, from initial to final. Your vertical displacement is also upward. Since we have three vectors, the initial velocity upwards, the vertical displacement that is also upwards, and the final velocity upwards, we will consider any vector that is going upwards to be a positive direction. Okay, that's it. So the y-axis in this whole thing is positive in the upward direction. But since the gravitational acceleration is downwards, it will have to carry a negative sign. So if we want to calibrate this equation, v square equals to u square plus basically 2gh, that's what you have learned for the Galileo equations or the free falling body equations. We need to calibrate it as for this case. And the calibration will go something like this: v square is equals to u square plus 2 into minus g into h is represented by y here. So this will be our calibrated equation. Please understand why did we do this? Because we need to contemplate the directions. The initial velocity has a direction upwards, you see here. The vertical displacement has a velocity direction upwards, but the gravitational acceleration is downwards, and we have determined any vector that is going upwards will be positive. So this is why we have calibrated this equation to this. And now, as you know, the velocity final will be 0. So what you do is you input the values here. V is equals to 0 squared, U is equals to 98. Let me do one thing. Let me just do this U squared minus 2GY. Okay, let me just do this here. And since we need to find out Y, we can say always Y is equals to U squared divided by 2G. Right? We can do that. So that should give us is equals to U square. The value of U square is 98 squared, and 2 into G, the value of G is 9.81. We will always use the value of G as 9.81 unless say otherwise. Okay. Anyways, so what will be the value? 98 squared divided by 2 into 9.81 gives us 489.5 meters. So that will be the maximum height. I know a lot of you will want to use h is equals to u squared divided by 2g that we have found here. You know, this is the formula or equation for maximum height that is given in the textbooks. But I always prefer people to do this math in the CQ section, for the CQ section. In this way, coming from the equation of motion of Galileo, because that's more explanatory, that's more easy, and you know, much more communicable. Okay, so your teachers will not find a flaw with it and give you full marks, hopefully, if you do this. So please try to maintain this. And if it's a MCQ question, then you go for this h equals to u squared by 2g. No one's going to do anything about it. But I would really request you not to use this shortcut formula in your CQ or written exams. Okay, you will see, you will understand why I'm talking about this later, when, you know, if you use the shortcut formula and the teacher crosses it and cuts your number with it. So that's going to be very sad, you know. Anyway, so let's move on to the next problem, next topic. It says if the object was thrown from 100-meter height, okay, how much time will it take? Since let's see one thing. If the object was thrown from 100-meter height, how will we throw? As it has given us in the starting stem, we will show it as it is. That means from 100 meters position, we will throw it vertically upwards. It will no longer go vertically downwards or in any other direction. Okay. If the object was thrown from a height of 100 meters, since that's what it says, we are going to throw it vertically upwards as mentioned in the stem. So now for the changed scenario, what we are going to do is we are going to assume this is a ground, and I pray and hope you all can build a building of 100 meters height, and then you go to the roof of that building and you throw the object vertically upwards from that building with 98 meter per second velocity. Okay. Now that's what it says in the question. Okay. So let us assume this is the height of the building, which is 100 meters, and we thrown the object vertically upwards. Now what will happen to this object? It will go up for sure, and then it will come down. Okay. And since in the question, how much time it would take to return to the ground, we have to return to the ground, right? The object needs to return to the ground. So right at the moment it will hit the ground, its velocity, its final velocity will be pointed downwards. See, now you need to understand very, very clearly that at this time, your object starts from point A and it ends its journey at point B. So what is the displacement? What is the definition of displacement? The definition of displacement is always from the initial position to the final position, the perpendicular distance from initial to final. So your vertical displacement now would be downwards. It will not be upwards. Okay. It goes up, it goes up, but then it comes down. So when it goes up and comes to this length, the whole of its displacement becomes zero. The upward distance doesn't count anymore for displacement because it returns to the same level, same length, right? So you need to count position A to be its initial position and position B to be its final position, right? You need to count it as your final position. Okay, you need to remember this. This is your final position. Okay. Anyways, so the displacement now is not along upwards. The displacement is now along downwards. Let us consider that displacement to be y. Okay, y is downwards, and obviously, where is the gravitational acceleration? It is pointed downwards. Gravitational acceleration is always downwards. So for path AB, what do you need to calculate? You need to calculate how much time would it take, right? So for that, you use this equation S equals to ut plus half of at squared, but we are going to calibrate it. After calibration, it should look something like this. Let's see. If we take vertically downwards to be positive now, right? This is a different map, so we can change our frame of reference. And as you all know, frame of reference basically means a coordinate system. In this coordinate system, we want to call the negative or positive side downwards. So if downwards is positive, X is given by Y. The vertical Y is the vertical displacement, right? Y is the vertical displacement. So this is Y equals to, where is U? U is pointed upwards. Y is downwards. You're coming down finally, but your U is upwards. So that will be negative. Minus ut plus half of gt squared because g is downwards, obviously. Now you need to just input the values. 100 is equals to minus 98t plus half times 9.81 into t squared. If you multiply it by 2, 200 is equals to minus 196t plus 9.81 t squared. Now, if you just, solve this quadratic equation, you will get the answer. So, let me just solve it. A polynomials 2, degree 2. So, amader, if you want to, rearrange this into an ideal polynomial, that should look like this: 9.81 t squared minus 196t minus 200 is equal to 0. So you can clearly see your A is 9.81, your B is minus 196, and your C is minus 200. If you input all these values, the time T is equals to 20.95 seconds, and another time is T minus 0.97 seconds. Okay, so as we all know, time can never be negative, so this would have to be cancelled out, and the only applicable time is 20.95 seconds. So the object will take 20.95 seconds to return to the ground if it was thrown from 100 meters height. Okay. Okay. So I hope this is clear now. Let's move on to the next question. See, it asks us two cars of the same mass from a distance of 200 meters advance with 15 meters per second and 20 meters per second velocity and collides after a certain time. Find out the time at which the collision happens. Now, a lot of people say there is a confusion regarding this question. And what you need to know is this question came in the board exam. And this is from Dinajpur Board, if I'm not wrong. Okay, this is from Dinajpur Board, DB, not Dhaka Board, Dinajpur. So how do I write Dinajpur? I'm not sure. DN probably. Dinajpur Board 2024, and similar type of question came in probably Chattogram Board 2023. So in two consecutive board exams in different boards, but it came. So you need to be, I think we all need to be a bit cautious about this type of maths, and that's why we are solving it, because also somebody gave us, Kadir Bhai gave us as a problem. So let's solve it. Now, the confusion that most people say it has is, it doesn't say if this 15 meter per second and 20 meter per second cars are moving in the same direction or they are coming towards each other. It doesn't say that. But to me, it's pretty clear. To me, it's this one. They are coming towards each other, because the first velocity you see here is 15. The second velocity is 20. If the car that is lagging behind, that's in 15, and the car that is in forward is 20, they're never going to collide with each other. Right? They're never going to collide. So this possibly can happen. And the board did not set the question as such. And so I am going to assume that it is going to be in the positive direction. See, most of the time these type of questions they do because they want to confuse you, and they want you to argue in the question and the exam hall that if this is correct or wrong, and you will wait for the correction to come and your time will go by, and that will create a problem, right? So we don't want to do that. We want to utilize our time to the maximum. So let's come and solve this problem. So what we do is we draw the figure, right? This is that road, let's say, where the two cars are moving from towards each other. Okay. So let's say at point O, we have the first car that is moving with 15 meter per second velocity. And in the opposite end, let's say we have the second car at point A, which is moving with a velocity of 20 meter per second. They're moving towards each other. Okay. And according to the question, the length or the gap or the distance they have is 200 meters. Okay, very cool. If this distance is 200 meters, you can safely assume if they collide with each other, they're going to have to collide at somewhere in the middle. Let's assume that point to be B. And let's also assume that point to be from X meter of distance from point O. So if it is from point O X meter distance, then from point A, it will be 200 minus X meters distance, right? So if you want to say that T is equals to 0 and T equals to 0 are same for both the car, that means they both started at the very same time, and after a certain time, T is equals to T second, they reach point B, you can write the equation for OB. You can write the equation for OB as the displacement x into velocity into time t, which here is x is equals to 15t. This is your first equation, right? OB is crossed by the first curve. OB is the first curve. Far east. What I'm writing? This is not far east, this is first. FIRST. Anyways, so for the first car, it travels to O to B, right? The first car travels to O to B to collide with each other. It crosses X meter distance in 15 meter per second and in T seconds of time. Since it's in uniform velocity, we are writing this equation X is equal to 15. And now for AB, that is the second car. The second car will follow the path AB. For AB, we can write 200 minus X is equal to the velocity times 20 into T. Now, what you can do is you can substitute the value of your 15T here into this X. X equals to 15T. So, 200 minus 15T equals to 20T. Now, if you just side transfer it, 200 is equals to 35T. So, the time T is equals to 200 divided by 35. Let's reset. 200 divided by 35 gives us 40 by 7 or 5.71 seconds. So time taken to collide with each other will be 5.71 seconds. I hope that clears it up. Here, collision happens means when the two cars will meet. Okay. Anyways, so that was that problem. Let's move on to the next problem. This is a very interesting problem. It says the radius of a tire. Sorry, it gives us the radius of a tire is 2 meters. And if the tire moves 180 degrees from the position of the figure, what will be the distance of the chewing gum? Right. So there is a slight correction here. The question will not be for distance. The question was initially for displacement. I'm sorry for the typing mistake here. The question is, what will be the displacement of the chewing gum, not the distance. Okay. The question is for the displacement. Okay. The displacement. Anyway, so distance, let me cut that out from here. What is the displacement of the chewing gum? That's the question. So in order to find out the displacement of the chewing gum, what I'm going to do is I'm just going to extend this path it had, or the road it had. Okay. And we are going to draw this chaka again. So I'm not sure if you guys can focus on the chaka here as much as I can, but I hope you guys can see. Okay, let me change the color of the chaka a bit. How do I change that color? Oh, there it is. Okay, so this is the chaka. This is the wheel. Okay, this is the wheel of the tire, whatever. So this tire moves 180 degrees from the position. That's what it says, right? So if it moves 180 degrees, that means it rotates. The chewing gum was in the bottom, and now after moving 180 degrees, the chewing gum will be now on the top, right? I hope you understand this. So what happens is there's a chewing gum here. You can see clearly, this is the chewing gum. It rotates, the wheel rotates, and the chewing gum is now on the top. And as a result, the center of this will also move. The center is not at the same place anymore, right? The center is now at this. So, as we know, if the tire moves one full revolution, if it moved one full revolution, if the tire moves one full revolution, then the linear distance it crosses is twice pi r, the circumference of the whole thing, right? But one full revolution means what? 360 degrees. 360 degrees, but it did not. It gave a half revolution, right? The tire gave a half revolution, meaning it only moved 180 degrees, right? So if it crossed the half of the angle, then the linear displacement would be what? The linear displacement would be half 2 pi r by 2 or pi r. So what we can see, what we can say is the center moved from this position to this position, and the distance for this movement is what? The distance is pi r. The distance is pi r. Okay. Now, what we are asked here? We are asked what is the displacement of the chewing gum. So we know if the initial position of the chewing gum is position A and the final position of the chewing gum is position B, so they are asking what is the length of AB. They are basically asking us what is the length of AB. Now to calculate AB, what we are going to do is we are going to draw this right angle triangle here. As you can see, we are drawing this right angle triangle here, and we are saying this is point C. Okay. Now if you closely notice at triangle ABC, if we say this is P and this is Q, this is PQ, right? PQ is the distance from center to the center of this object. So if we notice that in triangle ABC, we can say the length of AC corresponds with the length of PQ, first of all, right? And also, for triangle ABC, according to the law of Pythagoras or the theorem of Pythagoras, AB squared is equal to, we can say, AC squared plus CD squared, right? AB squared is equal to AC squared plus CD squared. Now, for the length of CD, as you can clearly see, the length of CD is basically the total diameter of this tire, which is 2R, right? So we can easily write AB as root over AC squared plus CD squared. We just input the value of AC, which is pi r whole squared, plus CD is 2r whole squared. If you calculate it, r comes out root over pi squared plus 2 squared. And if you calculate it, as r is given 2 meters, if you just calculate it, the value will be 2 into root over pi squared plus 4, 7.45 meter. So the displacement of this will be 7.45 meter. Okay. I hope you understand what we did with this problem. If you did not, please review this whole problem, and if you face any kind of confusion, please let us know in the comment section. Okay. Nice. Next, let's go and solve the next problem here. Let's see what is that. Oh, a mango in a tree of 120 meter height is the target of a stone that has a velocity of 20 meter per second velocity upwards, but the mango starts falling, detaching from its stem. Okay. At the same time, the questionnaire, there's a gap in the question. At the time when the stone is thrown. So this part is missing in the question. So sorry. A mango in a tree of 120 meters height is the target of a stone that has a velocity of 50 meters per second vertically upwards, but the mango starts falling, detaching from its stem at the time when the stone is thrown. Okay. Number C. When will the mango and the stone be equidistant from the ground? If we just draw the picture of the figure, it will be crystal clear to us what we need to do. So let's say this is the height where we have a mango, more looks like a guava, but nothing to worry. And let's say this is the ground from where we have a stone, and the stone will move upwards with a velocity of what? 50 meter per second. Okay. And when the mango releases, it does not have any initial velocity. So that's that be u1 equals to 0 meter per second. Okay. Okay. Now, when they ask you, when will the mango and the stone be equidistant? What do they mean? Equidistant from where? From the ground, right? So that means when the stone, let's assume the stone moves to point A from the ground, and distance y amount of, traveled y amount of distance, and the mango also dropped down from its height to the same A position. At that point, the mango and the stone will be equidistant, right? Equidistant from the ground. That's what they mean. What it means is basically when they will meet. When they will meet. Okay. Anyways, so if the bottom length is y, we assume, then the yellow length is 120 minus y, because the total length is 120, right? This total length is 120 meters. Okay? Okay, very good. So now for the mango. Now, if we write equation for the mango, it has crossed 120 minus y, this much of distance, from its initial point 0, right? Let us assume, since we have directional quantities here, one displacement, the yellow displacement is vertically downwards, but the red displacement is vertically upwards. So what do we need to do? We need to contemplate the direction, and let's say any direction that is vertically downwards is positive. So y is equal to half of gt square, because for the mango there is no initial velocity. So the total displacement of the mango is equal to half of gt square. Let that be number one. And for the stone, y is equal to, what you have to do is you have to give a minus y, because since we say all the vector that is in the negative direction, downward direction is the positive direction, so any vector that is upward will be negative direction. Minus y is equal to minus ut, because u is also upwards, plus half of g t squared, right? So now you can say, by multiplying it by minus 1, y is equal to ut. U means 50t plus half of gt squared. This is number 2. Now all you need to do is replace y. All you need to do is replace y from number 2 into number 1. So what was number 1? Let's write that first. Number 1 was 120 minus y is equals to half of gt squared. And what is y in number 2? 50t. So 120 minus 50t minus half of gt squared, right? That's what it should be. Yes. Oh, we did a mistake here. We did a mistake here, because if you multiply it by minus 1, there should be a negative sign here. There should be a negative sign here, and this should be plus here. Okay, so okay, that's it. Plus half of gt squared. Nice. Now what you need to do is plus half gt plus half gt squares cancels each other out. So 120 is equals to basically 50t, and t is equals to 120 divided by 50. 120 divided by 50 gives us 2.4 seconds. 2.4 seconds. The time at which these two will be, at the equal distance is 2.4 seconds. That's it. Okay. Now the second question is, after how much time of the mango will the stone drop to the ground? So the mango will drop to the ground, as you see, the mango will drop to the ground from upwards, and the stone, it will go up and then it will come down. So let's say the mango takes t1 time and the stone takes t2 time. We can obviously say that t1 time is better than t2 time. All you need to do is t2 minus t1. First calculate t2, then calculate t1, and then you just, find out the difference between t2 minus t1. And that's it. You're good to go. Great. Next, go for the last question. A mass of 0.2 kilogram is released from a height of 120 meters. What would be its velocity at the half height? Okay. So, basically, what we are going to do is, this is something of a 120 meters height, okay? So, this is 120 meters of height. You are dropping an object from that top, which is a mass of 0.2 kilogram. And since you are dropping it, so sorry about this. Since you are dropping it, its initial velocity is what? 0 meter per second, right? So what would be its velocity at half height? That means when it reaches to 60 meters of distance, what would be its final velocity? So you write v square is equals to u square plus 2gh. V square is equals to 2gh G is equals to root over 2GH, root over 2 times 9.8 times 60, 2 times 9.8 times 60, 14 root 6 or 34.29 meter per second. That's it. That's it. Anyways, it was a very simple problem. I hope you guys understood what we have taught so far. If there is any questions, please refer to us in the comment section or inbox us or knock us at WhatsApp. We will obviously get back to you. But until next time, Allah Hafiz.